In this video, I'm going to try to demystify the simplifying of trig functions. You know, it's funny because it's kind of an art working with this. I mean, we can try and put some rules out there to see what we can come up with, to see if we can find some generalities, but really it's a matter of being comfortable with trig functions and recognizing all the different ways that they work together. So by going into this video, you should be familiar with sine, cosine, and tangent. You should also be familiar with cosecant, secant, and cotangent and those relationships. And finally, you should know the three different Pythagorean identities. So if you don't have those, you should probably get those in front of you because we're going to be using those as we go through this video. So let's start by simplifying cosine theta plus tangent theta times sine theta. Now, where do we begin? I would say first angle of approach is to look at how you can break these things down into sine and cosine, because we've got a lot of different trig functions. We've got tangent, cosecant, secant, cotangent, but they're all based on some ratio or some organization or reorganization of sine and cosine. So if we can do that, that might help us simplify. So let's start by looking at tangent theta. So we know that that's going to be sine over cosine, so we just plug sine over cosine in for tangent, right? So now we're going to start multiplying everything together. We get cosine theta plus sine squared theta over cosine theta. Now, this isn't really simplified because now we've got a whole value and a fractional value, and it doesn't seem much simpler. So let's see if we can get it into one fraction and make it a little bit more simplified that way. So we're going to multiply our cosine by cosine over cosine. We're not changing anything. We're just going to rewrite it using a new notation or using a different way, cosine over cosine, right? Multiplying it by 1. So we're just kind of modifying the equation without really changing the equation, or the expression, excuse me. So when we do that, we'll get cosine squared theta over cosine theta plus sine squared theta over cosine theta. Now, again, just to reiterate, the reason I chose cosine over cosine is because cosine was in my denominator for the sine squared. That's a good reason to choose that for your denominator, or to choose that for your function that you're going to multiply one of your terms by. Okay, so now we've got our common denominator, so we can put all of our numerators together, cosine squared plus sine squared over cosine theta. Now we should recognize that this is one of our Pythagorean identities. So cosine squared plus sine squared, that equals 1. So we have 1 over cosine theta. And you could leave it there, but since we are familiar with cosecant, secant, and cotangent, we could also write it as secant theta. Okay, so that would be how we simplify this first expression. Let's look at a slightly more complicated one. So we're going to look at cosine theta over 1 plus sine theta minus 1 minus sine theta over cosine theta. Okay, so we're already in our sine and cosine kind of base values. So what do we do with this? Well, we might think, hey, let's cross multiply, but this minus sign in there, it's not an equal sign, so you can't really cross multiply. So what we need to do is we need to get a common denominator. If we get a common denominator, just like we did in the previous expression, maybe we can find some way to combine some of these things and make it a little bit simpler. So we don't have anything common now, so we're going to multiply the left piece, the left term, and the right term by each other. So the left term is going to be multiplied by cosine over cosine times cosine 1 plus sine. And the right side, we're going to multiply by 1 plus sine theta over 1 plus sine theta. So that will give us our nice common denominator. So we'll have cosine squared theta over cosine 1 plus sine theta minus, now I could distribute that cosine theta, but I'm going to hold off just to see if something else jumps out at me once I combine my numerators. And if nothing jumps out at me, then we'll distribute. Okay? So we're going to subtract now our 1 minus sine theta over cosine times 1 plus sine theta, 1 plus sine theta. So if you notice, we have the difference of, or not the difference of two squares, but two factors that are similar to the difference of two squares. 1 plus something, 1 minus something. So we know from our quadratics and all of our quadratic work that we've done that we can simplify this very easily to 1 minus sine squared theta. And we still have the same denominator as the other side, the other term. So now we're going to combine our numerators. Cosine squared theta minus 1 plus sine theta, sine squared theta, because we have to distribute that negative sign, and then we have our whole denominator as well. Well, just like the previous problem, we should see that we've got a cosine and a cosine squared and a sine squared. Okay, so that's going to go back to our Pythagorean identities. That's going to equal 1, and then also in the numerator we have minus 1, and then we have our denominator. Well, that should be pretty apparent that that's going to be 0, and it's a good thing that we didn't distribute that denominator, because that would have been some extra work, because in this case everything cancels out and we're just left with 0 as our simplified expression here. All right, we're going to look at one more, and we're going to show, this is going to be a little different, we're going to show that 1 minus 2 cosine squared theta over sine theta cosine theta equals tangent theta minus cotangent theta. Now, to show that these two things are equal, we basically have to pick one side and work it all the way through until we get to the other side. Now, again, there's not a hard and steadfast rule that you should always go with the left side or always go with the right side. It's going to be as you are comfortable with this. I generally start with the side that I can start breaking down into sine and cosine. I think that's generally a little bit easier for me. So that's the way I go about it. So I'm going to look at the right-hand side of this equation. And I'm going to rewrite tangent and cotangent using sine and cosine. Right? So here we go. We got sine theta over cosine minus cosine over sine. All right, so we can get our common denominator just like we did before by modifying this equation. We're going to multiply the left term by sine over sine. We're going to multiply the right term by cosine over cosine, and then we will find our numerator, get our numerator sorted. So we got sine squared theta over sine cosine minus cosine theta, cosine squared theta over sine cosine. Okay, so what are we going to do now? Well, let's combine our fractions. So we have 1 because as we're looking, we see that the left-hand side of the Brown equation is all one fraction, sine over cosine, or the denominator is sine cosine. So we're partway there. But we are left with sine squared minus cosine squared. So we need to ultimately get to 2 cosine squared thetas. Well, all right, how do we do that? We've already got 1. But we don't, and we have this sine squared piece in here. So how do we change this thing into a cosine? Well, it again goes back to our Pythagorean identities, and we're going to substitute in 1 minus cosine squared theta. So when we plug that in for sine squared theta, we can see easily that this is going to simplify to 1 minus 2 cosine squared theta over sine cosine theta. All right, so that's approaching it from the right-hand side. Let's see what would happen if we did it from the left-hand side. Now, we do have the benefit of knowing how we just work this. So technically, we could go from the bottom all the way up, start with the bottom yellow equation expression, and work our way back up. But let's try and do this as if we didn't realize that was going to happen. So we'll take 1 minus 2 cosine theta, 2 cosine squared theta over sine theta cosine theta. All right, so we want to get our denominator, we want that to go away, so we know that we're going to, and we also know that we want to make split this fraction. So in the numerator we've got 1 minus 2 cosine squared theta. So that means we could split that into two fractions. And because we have a tangent and a cotangent is what we're looking for, we know ultimately we have to get rid of this denominator, and we also have to break our fraction in two. Okay, so we'll start by doing that. So we're going to split it in two. We're going to take our 1, we're going to substitute in our Pythagorean identity, so we can get sine squared plus cosine squared, and that's going to be minus 2 cosine squared theta. So all I've done is I'm looking to see, is there a way that I can break apart this 1, right? Break it into something else, into our sine and cosine, that we can hopefully at some point get to a tangent. Okay, so now we want to break, we can recognize that these two things are roughly the same, right? Cosine squared and a cosine squared. So we can simplify those pieces. So we're going to be sine squared theta minus cosine squared theta over sine theta cosine theta. Okay, so now we've got two separate terms in the numerator with a common denominator. We're going to split this fraction. We're going to have sine squared theta over sine theta cosine theta minus cosine squared theta over sine theta cosine theta. All right, we can do some of our simplifying. We can knock out these sines, we can knock out these cosines, and we can simplify to sine theta cosine over cosine theta minus cosine over sine, and obviously that's going to go to tangent theta minus cotangent theta. Now, the expression we just worked through, it may seem like it took less steps, or it may seem a little bit easier, but again, we did have the benefit of working through the yellow equation first, so that does give us a little bit of help. But again, you can choose either side and figure out a way to kind of work it through and break it down. All you have to do is keep in mind what your goal is, what you're working with. So I hope this kind of helps determine some of the different ways you can tackle these, and we'll talk to you in the next video.